Hi students, welcome to class 12 physics video session. So in this today's session we are going to discuss the solutions of online MCQ test conducted on 20th June Saturday. So electrostatic potential and capacitance, the questions were asked in the whole chapter. So now let us discuss the answers. The first question. So 100 joule of work is performed carrying a charge of minus 5 coulomb from infinity to particular point in an uniform electric field. What is the potential at the point? Here we know potential is the V equal to W by Q, the work done by charge. Here work done is given 100 joule and Q is given minus 5 coulomb. So 100 minus 5 which is the answer, that is minus 20 volt. So also we can write the formula W is equal to VQ. So also we can find if voltage says if potential and charge is given, so work done may be calculated. So the second question. Here the positively charged particle is released in the direction of electric field. What is the potential energy? We know the formula for potential energy, that is definition. The potential energy is the work done against the electric field by the unit positive charge from the infinity to particular point. Here positive charge is released along the direction of electric field. So if potential energy increases, so opposite to the direction of electric field, but here it is released along the direction of electric field, so potential energy decreases because the charge moving along the electric field. So third one is the correct answer. So next question. The equipotential surfaces of great distance from the collection of charges whose total sum is not zero or approximately, which means the collection of many charges are considered at a great distance. It is considered as the single point charge, and we know that for a single charge the equipotential surface will be sphere, that is spherical shape. For single charge the potentials at various points in the spherical manner, so equipotential surface is drawn like this, the sphere. So the answer will be sphere. Next question. Two small spheres each having the charge q are placed r meter apart. So if one of the sphere is taken around the other one in a circular path of radius r, so work done will be, we know that, so here one charge is there and another charge is taken in the circular path. So the distance between the two charges are r and the displacement equal to this direction. So force is along the line joining the two charges and the displacement will be in circular path, so displacement will be this direction. So both are mutually perpendicular, the force and the displacement. We know the formula for work done W is equal to FD cos theta. Here theta equal to 90 degree, so cos theta equal to cos 90 degree equal to 0, so work done will be 0. So this is the correct answer. So 0 will be correct answer. Next question. The electrostatic potential and the surface of charged conducting sphere is 100 volt. Two statements are given. The statement 1, at any point inside the conductor is sphere is electric field intensity is 0. So we know that for any shape of conductor inside the conductor E equal to 0, and also we know potential V equal to constant. So second statement is given like that. At any point inside the sphere the electrostatic potential is 100 volt. So what is the answer, correct answer among the following? So here we analyze that first statement is true and second statement also true, and the same way we can say that the first statement is the cause of second statement, because second statement tells that the potential is constant. If the potential is constant, then electric field will be 0. We know the formula. The next question. Consider a uniform electric field in the z direction. The potential is a constant at which direction? So answers are given. So here electric field is z direction means, so there is not constant of potential in z direction. So then only electric field will be there. So apart from z direction, in all direction electric field is 0. So if electric field is 0 means the potential will be constant. So the options are given for any x direction for a given set, for any y direction. So both in x and y directions the potential will be constant, and in all space is not correct. So only x and y are xy plane. So these directions only the potential will be constant. So the exact answer will be both the above. So in the next question, the region of constant potential, we know that if V equal to constant, V equal to some constant, so electric field will be 0, we know inside the electric conductor. So the answer will be electric field is 0. Next question, 3 capacitors are connected in series. So what will happen? So if 3 capacitors connected in series, so the potential given between them are divided into among the 3 capacitors V1, V2, V3. In the same time the charge will be the same, Q will be same among the all capacitors. So answer is they will have equal charges. So this is the answer. Next question, if Q is the charge on the capacitor, E is the electric field intensity between the plates, then force between the plates of a capacitor is, we know the electrostatic force equal to F is equal to QE, where Q is the charge and E is the electric field applied. Here capital QE is the answer. Or simply we can write F is equal to EQ, that is EQ or EE, where E is the electronic charge, or EQ. So this is the common formula. So basing this, the capital Q into E is the answer for this question. So next question, a hollow metal sphere of radius 10 cm is charged such that the potential on its surface is 80 volt. What is the potential at the center of the sphere? We know hollow metal sphere, it's a conductor, so the potential will be same on the surface and inside. So the answer will be the same 80 volt inside at the center of the sphere. But according to the electric field is 0 but not equal to 0 in the surface. Only potential will be same both on surface and at center or inside the sphere, hollow sphere. So answer will be the same 80 volt. And next question, relation between the Coulomb force and the electric field. Already we discussed F is equal to Coulomb force equal to, or electrostatic force equal to, F is equal to QE. Q is the charge and E is the applied electric field, QE. So E equal to, we can write F by Q. E equal to F by Q. Next question, so all are direct questions. The relation between the electric field and electrostatic potential, it's very important relation, is V equal to E into dl. The same time E equal to electric field equal to V by dl, that is the gradient of the potential, negative gradient of the potential, which gives the electric field at any point. We know the definition and the relation between the electric field and potential. So the answer will be V equal to E dl. Next question, a hollow metal sphere of radius 5 cm is charged so that potential on its surface, the similar question is given, that is surface potential at surface is 10 volt. What is the potential at the center of the sphere? The same 10 volt. So similar question. Next one, the electrostatic force between the metal plates of an isolated parallel plate capacitor C having the charge Q and area A. So 4 options are given. So looking at 4 options, all are based on the distance between the two plates. But electrostatic force equal to formula already we discussed in the earlier questions, F is equal to QE, only depending on the charge on the plates and the electric field applied. Here options are given based on the distance between the plates. So force is independent of the distance between the plates. Okay, so the answer will be independent of the distance between them. Third one is the correct answer. So the electrostatic force is independent of the distance between the plates of the capacitor. Next, a capacitor is charged by the battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of the resulting system. So what will happen if two batteries are connected in parallel? Here four options are given. So already we know that the energy is equal to energy U equal to, that is 1 by 2 CV squared. 1 by 2 CV. C is the capacitance, V is the potential. Here initially one capacitor is taken, it's charged, and another capacitor is connected. So we assume that both capacitors are Q1, Q2. If two capacitors are connected in parallel, so voltage will be divided into two half. So voltage will be reduced to V by 2. So the energy will be, if V is replacing by V by 2, so squaring the V by 2 the whole squared, we get V squared by 4. So the finally the answer, the electrostatic energy resulting system will be reduced by the factor of 4. So decreases by a factor of 4 is the answer. Next question, the conductor with a positive charge. The question may be asked for the conductor with a positive charge of having which type of potential. So here we should know that the potential of a charge is respecting to the position only, not depending on the type of the charge, whether it is positive or negative. It may be the position on the external electric field. So a conductor with a positive charge may be a positive potential or negative potential or zero potential. So last answer is the correct. So the potential of any charge is with respect to the position in the external electric field. If positive charge is placed in a negative, the electric field due to the negative charge, so it may be it may be negative potential. So the last one is the correct answer. Next question. 64 drops, each having the capacity C and the potential V, are combined to form a big drop. If the charge on the small drop is Q, so each drop having the charge small q, so total charge on the big drop, we know that total charge equal to algebraic sum of the individual charges. We can q is equal to nq. Here n equal to 64 drops, so the total charge will be 64q. So this is the answer. Fourth one is the correct answer. So next, 1 volt is equivalent to, so 1 volt is the unit of potential V. We know the formula for potential, V is equal to W by Q. So 1 volt is equal to, for work done, joule, and for charge it is coulomb. So the 1 volt equal to joule per coulomb. So joule by coulomb is the answer. So next question, the work done in bringing a unit positive charge from infinite distance to a point at a distance of r from r of positive charge, q is W. That is, once again reading the question, the work done in bringing a unit positive charge from infinity distance to the particular point. So in the by the positive charge q is W. So W is the work done. Then the potential at the point is the question itself given by the definition of the potential. The potential is defined as the unit positive charge, work done by the unit positive charge against the given electric field from the infinity to particular point. The question is given there. So the work done is given by W. So it is the potential at that point. So the potential at that point is W. If you take unit positive charge, then work done is called potential, or potential energy equal to W by Q. Potential energy is equal to W by Q. So answer is W. Next question, the test charge is moved from a lower potential to a higher potential. The potential energy of the test charge will be, here the test charge is doesn't given, either it is positive or negative. if always you consider the positive charge. The test charge is considered as the positive charge. If the positive charge is moved lower to higher potential, we know against the electric field direction. That is, electric field is always positive to negative, higher potential to lower potential. So here positive charge is moved against the higher potential. So the potential energy increases. The answer will be increases. If you take test charge is negative, then it's opposite to the negative charge to positive charge. The potential energy will be decreases. If here a test charge is given, that's all. Whether it is negative charge or positive charge are not considered. So if you consider the positive charge, the answer will be increases. If you consider negative charge, the answer will be decrease. So always you consider test charge is a positive charge, and the answer will be the potential energy will be increase. So next question, the electric dipole of moment P is placed in a uniform electric field, then the torque on the dipole. Torque, we know the formula, tau is equal to, so already we get derived, tau is equal to Pe sin theta, that is P cross E. So which gives the Pe sin theta. It's a cross product, so which gives sin theta. So answer is first one. Next question, which of the following statement is true? The first one is the electrostatic force is a conservative force. It's very well we know that it's true. Electrostatic force is a conservative force. And the second one, potential at a point is work done per unit charge in bringing charge from any point to infinity. The statement is wrong. So second one is the wrong, not true. The electrostatic force is a non-conservative force. It's not true. The potential is a product of charge and work. It's not true. V is equal to, it's a product of charge and work done, W into Q. It's a not true, because V is equal to W by Q. W by Q is the true. So only the first one is the correct answer. Electrostatic force is a conservative force. Next question. The dielectric constant for the conductor is, exact answer is infinity. The same way the dielectric constant is, that is K is taken as epsilon by epsilon naught. So for air medium, epsilon naught, the permittivity of the air medium is epsilon naught. Here epsilon is the permittivity of the taken medium. So the ratio between them is called dielectric constant of that medium. For air medium, K equal to 1. For conductor, it will be infinity, because the electric field inside the conductor will be 0. So there is no permittivity. So the E equal to 0, and also K equal to infinity. Dielectric constant is taken as the infinity. The next question, in parallel plate capacitor, the capacity increases if area of the plate is decreased, the distance between the plate increases, area of the plate is increased, dielectric constant decreases. We know that the formula, the parallel plate capacity C is equal to epsilon naught A by D. So that is, capacitance is directly proportional to the area and inversely proportional to the distance between the plates. Here area of the plate is decreased, is wrong. Distance between the plate increases, it's wrong. So third option, area of the plate is increased. If A increases, C increases. That one is correct. And the fourth is not correct. So only third one is the correct. By using this formula, we can obtain the answer for this question. So next question, the energies U stored in a capacitor at the capacitance C and charge Q and voltage V. The formulas are given. I think all formula will be correct. So that is, energy U is equal to QV by 2, and if you substitute the value, Q is equal to CV, so 1 by 2 CV squared, and the same time we can obtain Q squared by 2C. So the answer will be all the above. So all formulae are correct. The same time, next question, that is electric energy density, the energy per unit volume. It's taken as small u. So the above question will be parallel plate capacitor, energy capital U, here small u, energy per unit volume. So we know the formula half epsilon naught E squared. So already we derived for that. In the textbook also we gave the answer 1 by 2 epsilon naught E squared is the very important formula. Next one, the dipole moment per unit volume. So already direct definition for polarization. Polarization is called dipole moment per unit volume. Dipole moment mu is equal to, we know that for dipole moment equal to charge into distance between them, q into distance between two charges, 2a, q into 2a. This is called dipole moment, mu or p, small p. So dipole moment per unit volume of the material is called polarization. So we studied in the dielectric materials polarization. When you apply the electric field to the dielectric material, polarization will occur. So that is called the definition for that. So next question, 1 picofarad means, we know that pico means 10 to the power minus 12. Pico means 10 to the power minus 12. So third answer, 10 to the power minus 12 farad is called picofarad. And next question, if two capacitors C1 C2 are connected in series, the effective capacitance. So direct question, C1 C2 are connected in series, the effective will be, that is 1 by C series equal to 1 by C1 plus 1 by C2. That is reciprocal of the effective capacitance equal to algebraic sum of the reciprocals of the individual capacitors. So if we simplify this equation, we can obtain C1 C2 by C1 plus C2. So second one is the correct answer. The next question, which of the following is correct? K, dielectric constant equal to epsilon by epsilon naught. So all are same question, same formula. So the first formula we can deduce that epsilon equal to epsilon naught K, and also K equal to 1 for free space or for air medium, and K equal to infinity for conductors. So we know all are correct answers. So the exact answer will be all the above. So 30 questions we have discussed here, and so almost direct questions. So you just go through the entire NCERT content, and you do the numericals and do the answers for exercises and for examples. Then only you can able to solve any type of problems, any type of questions, any type of descriptive and multiple choice questions. So you should be thorough in your content. Mainly you go through the NCERT book. So thank you students.